Adding parallelization to a Rust application can be on the one hand pretty easy and pretty straightforward, but on the other hand sometimes be really challenging. And obviously you can complicate your life if you have a bit more complex application than what we have actually in this video here. Because in this video we are going to parallelize our CLI application that we've actually built in the first part with the help of Futures and Tokio, where we are going to just simply parallelize our HTTP requests. Now, like I said before, this is the second part of this kind of mini series where we're going to build a CLI tool with the help of the GitHub API and Rust. So let's just get started. Now, it is important to note that this video is not really for someone who's new to Tokio or the overall asynchronous functionality of Rust. I'll probably make a separate video just about this whole asynchronous functionality runtime stuff of Rust. Now, we've identified some minor issues in the last episode and also some refactoring possibilities. And the first thing that we can really refactor here with this whole code and make things even more clear is by making use of structs in Rust. Now, why would we actually use structs? It's pretty simple. The first reason is that we do not want to repeat ourselves with, for instance, the GitHub token, owner or repository pass into our functions. And also we can kind of control the visibility of the functions in our struct. Because obviously it makes sense if we decide to kind of publish this code to a publicly downloadable crate, then obviously we want to kind of restrict the visibility of our functions in the struct. And also coming back to our other issues, we've also identified like a smaller issue with the construct new URL function, which we are going to also fix in this episode. Okay, so let's start by just adding a new GitHub API struct. So we've actually created a couple of structs before in the first part, but now let's just focus on creating a new struct called GitHub API. Now, this GitHub API is pretty simple and pretty easy to understand because we are going to kind of refactor all the functions into this struct, right? Into our GitHub API struct. So let's start with the fields of our struct here. We've actually identified that we quite recently or often use the client, right? Which is of type request, right? Of the package request or of the crate request with a W. And then we say client, right? So now we actually have a client of type request client. Then we also need the token, the user agent, probably also the owner, right? The owner of the repository. And then we also need the repository itself. Right, and obviously I come from another language, so we just capitalize the string here. All right, now we have our struct, so let's just start with our constructor here. Right, so what we're going to do is impl, and then so the implementation now starts for our struct. And now we can add all our functions. And we're going to start with the new function, which acts as somehow a constructor-like method. Right, and obviously we want to return self here, which in the end is the GitHub API. And now we want to kind of pass in all the string fields of our GitHub API. So we say token and then string. We have user agent, string, owner, string, and then the repository, which is also a string. Right, so let's quickly format this. All right, that's pretty cool. And in the end, we can return the GitHub API and just pass in all these string fields. Now you might notice that we don't have the client here, so let's quickly create this. So we say client, and then we basically make use of this line here, right? So we kind of create in every function at this very moment the client, right? Which is unnecessary because we only need one initialization of our client. So we can basically copy this, right? Then go back to our constructor and then pass in the client here. And then we pass in the client into our struct. So now we've created a GitHub API struct. All right, and now what we're going to do is just move all the necessary functions we can actually include in our GitHub API struct, right? So you might think that we can obviously abstract this a bit more, but I'm going to keep things really simple here and just copy paste all the functions we have because they kind of interact with the GitHub API, the official GitHub API. And that's why we're going to just copy all the functions into the implementation of our GitHub API struct. So I'm going to copy these and then I'm going to just pass them in here. Right? And now we obviously want to make use of self, so we're going to include self in all our functions here. So we are going to say self, right? And then we can go to the next function, which is get issues wrapper. Now this function is going to get a little bit interesting here, but for now we just say self, right? Now going to our get issues, it's the same thing. We just say self, right? Can format this obviously to make things a bit more readable for you. And then let's get to our get issue reactions. And here we sell self as well. So let's just fix all the issues we see here with like the function names and all that stuff, because obviously we have to reference now self. And after that, we are going to actually see an issue with the get issues wrapper function. So let's just say self, right? Get issues. Let's quickly scan this code quickly. We have to construct new URL here as well. So we say self here as well. Here we have the get issues wrapper. So we say self.get issues wrapper as well. And that should be about it, right? Now we actually see an interesting issue with our get issues wrapper. And the issue actually is if we just hover over the error itself, it just says that the lifetime may not live long enough. Returning this value requires that some kind of lifetime modifier must outlive static. Now the problem with this function is, and the reason why we cannot use static is actually pretty simple, because static would mean that the future does not depend on the references that could go out of scope. And because we are referencing self here, the future cannot be guaranteed to live for the entire duration of the program, or like be independent of that reference. Now what that really means and what we actually need to do is just declare a custom reference here. So what we're going to say is before the get issues wrapper, we say the lifetime modifier, and then we are going to specify the lifetime for our self reference. And then instead of using static, we just say a, right? And that should fix the issue. Now you might wonder why this actually works. And interestingly enough, this a lifetime ensures that the reference to self is valid for the duration of the future's execution, right? And prevents kind of these dangling references. And in the end, this lifetime modifier tells Rust really that the future returned by the function cannot outlive the lifetime of self. And this really ensures that any data borrowed from self is still around while the async operation runs. Hopefully this makes sense here. Alright, with that in mind, we can now quickly refactor the functions itself. And what we can do now is we can rid of a lot of stuff here. We can get rid of the token because we are initializing the token inside the main function, where in the end we are going to initialize the GitHub API itself, or the struct of the GitHub API. Then we can get rid of the client, right? Because the struct itself has a client field, right? And the rest stays more or less the same. What we can do here is obviously enhance the owner now and the repository itself. So what we're going to do, instead of having a fixed value here, we just say self.owner, and then we say self.repository, right? So that's pretty cool. Now we can say self.client for referencing our request client. And here for token, we just say self.token, right? Let's just format this. And instead of having a fixed value for our user agent, we can now refer to the user agent field of our struct. And in the end, we need to kind of borrow this field here, right? Okay, and I think that should be it for this function. Let's go to the next function, which is the get issue reactions function. Obviously here again, let's just remove the client here again. We can get rid of the token. We can say self.owner, right? And then we can say self.repository. And if I'm not mistaken, yeah, we also have the token here. So we say self.token, right? And obviously we need to say self.client here as well. In terms of user agent, it's the same thing. So we are going to borrow the user agent here. And then that should be it for this function. Now, how do we actually initialize the GitHub API in our main function? We basically do the same thing, right? So we kind of get all the environment variables from our .env file, and then we just initialize the GitHub API. So what we're going to say, because we are loading initially the environment variables from the .env file, we can just say std env var, and then we say user agent, right? And then we say expect, and here we say expected user agent in end file. And then we can save this in a variable user agent, right? Now, it is important to know that you can also leverage tools like clap, right, to pass these arguments more cleanly. But I'm going to keep things really simple here without a lot of libraries. So let's do the same with our token. So we can say token, and then we say here token capitalized, and then expected token, right? So right now we do get these two variables from our environment variable. So now we need to get the owner and the repository from our CLI, from our command line arguments. And what we can leverage is the args function here, right? And the args function actually returns the arguments passed in from our CLI, right? So what we can do, or what we actually want to do, is like cargo run, and then this is our owner, right? And then we say Obsidian iconize, for instance, the repository itself, which is publicly available on GitHub. And then the kind of count or limit in this case. I'm going to go into dev into this here a bit later, right? So we want 3 CLI arguments. So we say .nth1, right, which is the first argument. And here we say owner name is required, because in the end, my name or my GitHub username is the first argument. We can save this in the owner variable as well. Let's copy this and let's just say repository, which is the second argument here. And that should be it for now. Now you might actually wonder why we do have to use this double dash, right? And the reason is because it is required to kind of separate the cargo's own arguments, right? Which could be like dash dash offline, for instance, from the actual arguments intended for our program. So that's important to know here. And that's why we actually started 1 instead of 0. All right, now a small side note, which is also important to know here. Having this .expect functionality is alright for a simple CLI script, right? But especially for larger systems, you can really consider graceful error handling here instead. Now also we could improve the error handling by using enums, for example, and instead of using strings for these errors, we could leverage this error enum instead. But besides these, we could also make use of error propagation instead of using all of the kind of nasty expect functions. So we can improve this a lot, but I'm going to skip this for now. All right, so let's just initialize our GitHub API by just saying GitHub API. And then we say GitHub API, we use the constructor, right? And now we pass in all our kind of variables here. So token, user agent, owner, and repository. Right, and now we can say GitHub API dot get issues, right? And then we say GitHub API again dot get issue reactions, and that should be it. And things should work fine. So if we say cargo run, so obviously right now the 30 has no real meaning here at all, but we are going to implement this in a minute. I'm just going to demonstrate that things should work as expected. All right, so let's just first start by fixing the construct new URL, because if you actually run this command, I actually showed you a minute ago, you might notice that we kind of are in an infinite loop. And the reason for that is because the construct new URL is wrongly implemented. So the problem with the old logic was that it is really error prone because it did not respect all the possible link headers inside the header itself. So currently, initially we go to the first page, right? And then to the second page. And then we go back to the previous page, resulting in this infinite loop. And what we can actually do to demonstrate this error-prone behavior is to just print the actual URL, right? So let's go to this let new URL. It is right here. And then here we can simply print line something. So let's say print line, and then we debug something really simply here, right? So we print the request URL, and then we are also going to print a new URL. Let's just see what happens here. Let's run the program again, and I will terminate the execution right now. And what we actually see is the request URL is this here, right? Which looks correct. We are on page 1 per pages 50. Right? And then the next page, right? Or in this case, the new URL is going to be the second page. Now, if you look at the second print line here, we see that the current page is page 2, which looks good. However, the new URL is page 1. And that is obviously wrong behavior. And this kind of results in this infinite loop. So let's quickly fix this issue here. Let's get rid of the print line and then go to our construct new URL. Because what we actually do not respect with this function is the handling of multiple links inside of the header, right? So what we can say, let's just maybe comment this out for now. And what we can say is just split the link value by a comma, right? And then we can say dot find map. In here, we are going to say link value. And then in here, we need to do some checks, right? So basically we now check if like the link actually contains the next kind of link to the new URL. Let's just rename the link value to link here, right? And if it does not contain the link, we just return none. And in here, we obviously need to return something as well if the actual link contains the next URL. And what we can say inside here is really similar to the logic we had before. We are going to split by the semicolon. Then we are going to take the next value, which basically is the same as like getting the URL part before the semicolon, right? Which is the same as this like get at 0. And then we're going to say map URL, and we say url.trim, and then trim start matches. Going to do it right now like this, right? Because I'm running out of space, but obviously feel free to format this by yourself. And we're going to obviously trim by this, and we're obviously going to trim by the closing caret here, right? So this was also explained in the first part, so feel free to check out the first part if you haven't already. And then in the end, we're going to say toString. Now we're going to remove the semicolon here, and that should be it, right? So this is the whole logic here we have, right? Sorry for the formatting right now, but let's just remove the comment, right? Because we don't need it anymore. And now we've actually fixed the issue with our construct new URL function, right? So if we run this code again, it should work. And what we see is actually the issues popping up and the reactions as well. Now coming back to our asynchronous functionality, let's just create first of all the limit variable, right? Which obviously also comes from the command line arguments. And then we take the third, right? The third line argument. Then we say expect, and then obviously limit is required. But then we also want to pass it directly to a usize, right? Because in the end, it should be an integer. And then we say expect, and then we say limit must be a number. And obviously, it's important to know here that this should be a usize, right? So an unsigned integer, it should be above 0 in this case. Obviously, 0 or less than 0 doesn't make a lot of sense. But I'm going to skip this check here for now, just to kind of really simplify the solution. All right, now our first asynchronous call was, as you can remember, the getIssues function call. And at this very stage for our kind of mini project, the issues at the moment cannot be fetched in parallel because we have to know the next page, and therefore each subsequent page URL kind of depends on the previous response, if that makes sense. And one solution we could implement in the future maybe would be to fetch the issues and in parallel fetch the reactions at the same time. But that would be obviously too complicated just for now for this video, right? And what we're going to do now is we are going to create a futures unordered. Now, what does that line actually mean here? And this line really means that we prepare a futures unordered to handle concurrent fetching of reactions for each issue. And this really allows to manage and poll multiple futures concurrently without strictly waiting for each future in sequence, right? And in the end, it yields as soon as each future completes, rather than waiting for each or for all futures to finish. Alright, so with that in mind, we can now go ahead into the issues loop here. And what we're going to say is we are going to say issue number is equal to issue.number. I'm going to explain in a minute here why we are actually doing this. And we're going to do the same thing with the GitHub API reference, right? And then let's just say futures dot push, because now we're going to add an asynchronous block to our futures unordered. And here we say async move, and then we say let reaction. So basically this line here. And then in the end, we say issue number, right? We return a tuple, issue number and reactions. And then we can also remove the 2 print lines here. So what does that all mean? And why do we actually do it this way? And I actually forgot to use the GitHub API ref instead, right? So that's really important to know here. So why do we actually do this? Now this kind of copying of the issue number and the GitHub API itself is required because the instance is being moved into the asynchronous block, right? Because we also use the move keyword, and we have to use the move keyword here. I've also made a separate video about the move keyword itself, so feel free to check out this as well. Now this really means that the GitHub API itself cannot really be used again in subsequent iterations. Because in the end, this move keyword takes ownership of the GitHub API and the issue number. And this kind of declaring of the instance or the issue number and the GitHub API really allows to use the same instance across multiple asynchronous blocks, right? Without really transferring ownership at all. And here, like I said before, this asynchronous move block is actually an async closure, right? And this will take ownership of the variables it references. And then each spawned asynchronous task can then safely use the GitHub API reference by value without really worrying about borrowing it after the main function continues. And that's why we actually do this here, right? All right, last but not least, we obviously want to consume all the futures. And what we're going to do, because we have the limit as well, we're going to quickly create a mutatable hash map here, where the key and the value is a usize. And we're going to say hash map new. Now in the end, the results hash map just should contain the issue number as the key and the reactions as the kind of value, right? In this case, we are only focusing on the +1 reaction, right? Which is really important. So +1 just means a thumbs up. So in the end, we have, for instance, the issue number 319 with 5 thumbs up, right? This is a hash map entry here. So let's fill in this hash map by quickly iterating over our futures. And we can actually leverage here sum and then issue number, right, which is the tuple, and then reactions is equal to futures.next.await. Right, and this really means that while we can get the issue number and reactions in the next future, we just execute the logic here in the while loop. Right? And what we can do is we can actually count the reactions here with the +1. So we say reactions dot iter and then dot filter, and here we say r.content is equal to +1, and then we say dot count, right? And this just basically returns all the reactions with a +1 with a thumbs up as a kind of count. And then in the end, we just want to insert it into our hash map. So we're going to say entry issue number. This just allows to kind of get the key in our hash map, the key value pair in our hash map. And we can now manipulate this in place as well with this entry here, right? So what we can do is end modify. So if the entry exists, right, we just say E, and then we just want to say reactions count, right? So we say plus equals to reactions count. Now, if it does not exist, which should be kind of always the case, right? We just say or insert reactions count. And that's basically it, right? Now we have a hash map with all the issues and the reactions, thumbs up reactions in this case, right? And then what we can actually do to sort things would be to just make use of basically the hash map, which is results. Then we say into iter, and then we say sort by A and B, right? And in here we use B1, which is the count, the reactions count, and then we say 1 as well. And we only want to care about the count and only sort by count in descending order. Right, and I actually forgot to just say sorted results here, which in the end is results.intoIter, right? And then we just say sorted results.sortBy. And here we have to define the type as well. and we have to use collect here. And what does this line do? It actually collects all the key value pairs of our hash map into a tuple and then stores it in a vector, right? And in the end, we just sort here in descending order by the count, right? So one more thing, I actually forgot that we do not want to care about issues that actually have no reactions at all, right? So what we can do is, like, if the reactions count is greater than 0, then we want to execute this code here, right? So we say entry and then modify and then or insert, right? So in the end, if we now print the sorted results, let's just do that. What we get, let's just say 30 as the limit. We do get in sorted order or in descending order in this case, the issue number, and then also the reactions count where the thumbs up emoji was applied, right? And what we can do now is just prettify these results with the limit actually. So we can make use of chrono, right? And now we kind of get the UTC date. So in the end, chrono is just a really popular crate for doing operations with dates and all sorts of time operations. And then we can just add a simple print line statement here, right? Which just prints the now date in a specific format. And then in the end, we can just iterate over our sorted result, right? So what we can say is index issue number. This is, by the way, just an example, right? A really messy example, I would say. Sorted result, right? Which is the created variable of the sorted result. .iter.enumerate, right? And now it actually returns an index, which is just obviously the index and then the tuple issue number and upvotes. And then we just check if the index is greater than the limit we just break. Obviously, there's a better way to do this, right? I'm just going to leave it up to you if you do it this way or the more rusty way, I would say. And then we just print line something here. And we're just going to print like the index, which is the first, right? So obviously we want to display like a sort of ranking of our issues. And this is where the index is actually used, right? Then we just display the issue number and the upvotes as well. So if we now run this program, everything should work really fine and really fast as well. And in the end, what we will see is basically a list of issue numbers, right? Which is 380. And this is the most upvoted issue in our GitHub repository here, right? And now hopefully you understood everything what we've done here. To reiterate quickly, we just created a futures unorder up here. And we pushed in an asynchronous block, which is non-blocking at all, right? We just push in all the asynchronous blocks that we want to execute, right? And then in here, we kind of execute or await the next future. And then we obviously execute all of the logic, which is accumulating the reactions count and then just modifying our hash map to have this kind of key value pair. All right, congrats on making it so far. Clearly there's a lot more to improve here, so feel free to clean up some things or even improve the application or parallelization itself. So for example, the GitHub API has rate limits, right? Or has an in-place rate limiting. And you can actually detect this hit of the rate limit by just reading certain headers. Now it's important to know that I've also used the move keyword here, which can be quite hard to understand sometimes. Luckily, I've also made a video just about the move keyword in Rust as well, so feel free to check out this video. Thank you so much for watching, have a lovely day, and bye bye.